Hello. Today we're in the fifth activity of the while loops chapter in Learn to Code 1. This activity is called Turned Around. Turned Around. So the challenge here is to choose tools that will make our solution as efficient as possible. So what do we mean by efficient? Well, we mean probably not a lot of wasting time from byte going across the grid, say, for example, picking up one gem on one side, then walking all the way over to the other side, and then walking all the way back to the other side, and so on. So we want to sort of collect gems near each other as much as possible. Now, we're going to use any of the tools that we know so far. So just to review, we've learned about functions. Functions are little blocks of code with a name on them, and those blocks of code are meant to represent some abstract idea. Probably the simplest one we have is turn around. There is no function turn around that comes with byte, but we can take two turn lefts or two turn rights and put a name on it called turn around, and anytime we call turn around, then we'll actually do those details, two turn lefts or two turn rights. For loops. Again, it's a block of code. In this case, the block of code gets executed over and over and over again some number of times. And we define the number of times that we want to run that block of code in the beginning of our for loop statement. Conditional code, another name for this is branching code. And this is this basic idea where we can ask a question about the state of our environment or the state of our program. And if the state is true, we can do one bit of code, and if it's false, we'll do a different bit of code. And inside these conditional codes, we can make more complex conditions to test for using these logical operators like not, which is the exclamation mark or bang symbol, or the double ampersand, which means and, logical and. So we might say something like, if we're on a gem and we're blocked, then do this, else do something else. The other logical operator is the OR operator, which are these two vertical bars. And we might say something here like, if we're on a closed switch or we're blocked on the right, then do this. Okay? And our last tool in our toolbox is while loops. And while loops, again, are this block of code or block of commands which we run over and over and over again, but instead of being some set number of times, this block of code will execute as long as some condition is true. And as soon as that condition is no longer true, it will stop. Okay, we'll go down to the code after the while loop. All right, let's take a look at this turned around puzzle here. I'm going to pinch to zoom out, and I'm going to tap on the screen to rotate it left and right. And notice basically it's a square, right? It's a square with the corners knocked out of it. And each side of the square has 4 tiles. So 4 tiles here, 4 tiles here, 4 tiles here, and 4 tiles way over here. But the corners are kind of obstructed by either rocks or platform tiles on platforms. So how should we tackle this? Well, we want to, again, we don't want to be walking back and forth across this puzzle, across the middle, which probably means we want to handle gems nearby each other. And one thing that's nice about a square is you may notice there's some symmetry here. Okay, the left side here is just like the right side as far as the gems go in their configuration, and the top row is a lot like the bottom row as far as its gems, the configuration of its gems go. Okay, so we can maybe then, a lot of times if we're looking for patterns that we can repeat, symmetry is often a good way to start. So in this case, if we say the whole top half is similar to the bottom half, meaning if we can take care of the top half with this gem, this gem, this gem, and just this gem, and we divide it along this left to right line right here, if we can take care of the top half, if we have a function that takes care of that pattern of gems, we can call it again on this pattern of gems to take care of the bottom half. Okay? The same thing as if we divide this puzzle in half, again, because it's symmetric, it works the same on the left and the right. So if we divide the puzzle down the middle vertically, then if we take care of the left-hand side, this gem, this one, and this one, we can use that same function to do the right-hand side. Okay? So there's one possible way to do it. Also, things symmetric, we could divide this in half a different way. Let's divide it in half along the diagonals. Okay, what I mean by that is maybe let's divide the puzzle in half from this corner to this corner over here. And then if we write a function that takes care of these 4 gems on this half, here, 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 and here, then maybe we could make a for loop that goes from 1 to 2 and execute that function once for this half and once for the top left half. Okay, we could do the same thing dividing it along this diagonal from the one rock to the other rock. And it would be similar. We could take care of the bottom left half first, and once we have that function, we could take care of the top right half first. All right? So that symmetry lets us cut it into 2 equal parts, and that lets us write a function that we could take care of one half and then take care of the other half. But if we can cut it in half, we might also be able to cut it in fourths. Okay? What if we took the diagonals, and instead of just one diagonal going across from here to here, let's add another diagonal that goes across from the rock to the rock. That divides the puzzle up into 4 similar pieces. So here we could write a for loop that goes from 1 to 4 and call a function that would take care of these 2 gems, then these 2, then these 2, then these 2. Okay, so 2 at a time, 2 gems at a time. Well, if we can cut it in fourths along the diagonals, we could also probably cut it in fourths from one side to the other. So let's divide it from left to right along here and from top to bottom here. And then we're left with the 4 corners to take care of. So if we had a function that took care of one of these corners, like here and here, we could call that function 4 times, taking care of 1 corner, then 2 corners, then 3 corners, then 4 corners. Okay, so lots of possibilities here. After we do this one example, I'm going to talk about this other possibility, which I think is a little bit more interesting. But let's take care of this one first, just as an example. I want to do the one where we divide it in half along the left side to right side and top to bottom. So we have 4 corners to take care of. So I'll put a little comment in here that says, solve this puzzle using 4 corners approach or something like that. That's just a name I'm making up to tell me what remind me of what I'm doing. Okay, to solve this puzzle using the 4 corners approach, I'm first going to get byte over into one of the corners here, and let's work on the corner that's off to our right. So to get byte over there, I'm just going to move forward. I'm not going to collect the gem there. I'm just going to turn to the left and one more move forward. Okay, that will put us over into this tile right here under the gem, and we'll be facing the wall here. So the first thing we want to do is let's write the function that handles these 2 gems in this corner right now. Okay, func handle corner. And to handle this corner, well, we're on a gem right now. So let's collect that gem. Then let's get set up to go to the other, to go around the corner to get to the other tile with the gem on it. So that will be turn left, and that'll be a move forward, and then a turn right, and a move forward. And then we'll be under the gem, so we can collect the gem at that point, the second gem. And that's all done. We're done taking care of this corner, but it might make it easier for us to get to the next corner with these two gems on it if we're facing that direction. So part of handle corner will get us set up to go forward into the next corner. So all I need to do to get set up to do that is to turn left so that I'm facing the next corner. Okay, let's just try this once and make sure this works. Handle corner is our function. So at the end of this, we should have these two gems taken care of right here, and we should be facing the next corner in the upper right hand corner if this all worked out well. So let's check it out. Okay, we're not doing anything with that gem. Here we're going to collect this. We're going to round the corner, collect this gem, and turn to the left so that we're ready to go. Okay, so this sequence of commands, handle corner, then move forward, and then handle another corner. Hopefully we can do the handle corner, move forward 4 times, and that will do the whole puzzle. But let's just make sure it works if we try it twice here. Okay, here's handle corner the first time right now. Takes care of this gem and this gem, and we end up facing this way. Now we move forward and call handle corner again, and it looks like he's taking care of it as long as he turns to the left, faces it. Yep. So we could call that 4 times, and that should work out just fine. So let's put that in a for loop. For I in 1 to 4, we want to call handle corner and move forward 4 times. That should handle the 4 corners and have us get all the gems. So let's go ahead and run the code. Remember, these 3 lines here just get us to the starting corner, and then this is really the main body of our loop, which takes care of everything. So let's step through the code. Here are the 3 lines that get us into position. Now, the first iteration of our for loop calls handle corner, right? Collects gem, turns left, moves forward, turns right, move forward, collect gem, turn left. Now back in the for loop, we move forward 1 and we call handle corner again. You'll handle this corner, end up facing the right way, move forward, handle the 3rd corner. Notice we can talk abstractly about handling a corner now because we have a function that takes care of all the details of handling a corner. Handle corner just takes care of all the gems on a corner and even gets us set up for the next corner. Okay, that's it. We did it. Okay, again, that's one solution, and we came up with this solution by recognizing that the puzzle was symmetric. It's a square, and if we divide that square into half and into quarters, we can take care of 1/4. We can write a function that abstractly handles 1 corner and then just have to call it 4 times, along with 1 simple command to move and get us ready for the next one. Okay, but now we're going to do this one a little bit differently here. So if you want to, you can save this code here. Maybe put it in comments or something. I'm just going to wipe it out for right now. So I'll wipe it out. You can always go back in the video if you want to see what we did here. And I want to think about this problem a little bit differently. So we solved the puzzle using this 4 corners approach. Now, how else can we think about this? Let's run to get us reset to the beginning with all of our gems. Oops. Okay, there we are. We're set up with all our gems. Now, what else do you notice if we just ignore the symmetry for right now? What do we notice about the configuration of the gems? Are there any gems in the middle of the puzzle? No, right? All the gems are located on the edges of the puzzle, all along the outer edges of this square. Okay? So, if we could find a way where we could just always walk around the edges of the square, picking up gems if they're there, we could solve this puzzle, right? Okay, so our plan will be, let's get to the edge of the square, and then let's walk around, always staying on the edge of the square, picking up gems until we have all the gems. Okay, sounds easy enough. It's not too bad either. So let's do the first part first, which is just get us to the edge. Okay, and we're facing the edge right now, but we're not quite there. So I'm going to change this comment here quick. Solve the puzzle by walking around the edge of the island collecting gems. Okay, a little easier said than done, but let's try it. So first thing we're going to do is move forward to get onto the edge. Move forward, get on the edge, and I'm also going to turn left so that I'm facing the next gem along the way. Okay, if I run my code here, I haven't collected anything yet. I'm just facing this way right now. Okay, now the first thing I'm going to worry about, I'm not going to worry about collecting the gems right now. I'm just going to worry about finding a plan that will let us walk along the edge. Okay, never leaving the edge. We don't want to go to the middle tiles if we can help it. So what does it mean to be on an edge? Okay, what does it mean to be on the edge? Well, there's always going to be something on our right-hand side, right? Maybe a wall or a cliff or something like that, right? And the way we note that in code is that we're blocked on the right. So as long as we're blocked on the right, we know we're on the edge. So we could check things like that. We could say something like, if we're blocked on the right, is blocked on the right, that's good. If we're blocked on the right. Now, if we're blocked on the right and there's nothing in front of us, then we want to move forward, right? Move forward. There's nothing in front of us. So if there's nothing in front of us, I need to say if we're is blocked in the front of us. If we are blocked, if there is something in front of us, we don't want to move forward. We can't move forward. So in the next square up ahead, we'll be blocked both on the right and in front of us. The only thing left to do then is to turn left. Okay, so we'll have to turn left. So we'll turn left and we need to get away from that wall, so we'll move forward in that case as well. Okay, so if we're blocked, we're going to turn left and move forward. But if we're not blocked, we're just going to move forward. Again, there's something on our right-hand side, so that means we're along the edge. Okay, let's try this. In fact, I'm going to put this into a function right now. No, maybe not a function. I know what we'll do. I know what we'll do. We'll just do this over and over and over again. Okay, so I'm going to say while something is true, and what's always true? True is always true. While true, we're going to keep doing this over and over and over again. Now, since true is always true, whatever is inside this while loop is just going to happen forever and ever and ever. It's an infinite loop. It loops for infinity. So I want this code to just keep looping over and over and over again. Okay, so for right now, that's what we want. Just to see if we'll walk around the square. So let's watch what happens if we do this. So again, what's going to happen is we're going to check if we're blocked to the right, that's good. That means we're on the edge. But if we're blocked to the front, that's a little bit bad. We need to turn left and move forward. But if we're blocked to the right and we're not blocked in front, then we're going to come down here and do a move forward. So I need to put that in an else. Else, just move forward. Okay, so that says exactly what we want. If we're blocked to the right, we want to check, are we blocked to the front? If we're not, we just move forward. But if we are blocked to the front, then we just turn left and move forward. So let's see what happens here, at least to the beginning. Okay, we're coming over, we're turning right. Here we're running our while loop. And we move forward and, okay, doesn't know what to do there because he's not blocked to the right anymore, is he? He's not blocked to the right. So if he's not blocked to the right, that means he's gone away from the edge, right? If there's nothing on his right-hand side, he's gone away from the edge. So we need to put an else in here that says if you've gone away from the edge, you need to get back to the edge as quickly as possible. And the quickest way back to the edge is to say turn right, because that's where we know the edge has to be over there somewhere, and move forward to get yourself back to the edge. Okay? Let's try that, see if he gets past this block here. Okay, he's walking to the edge, he turns left. Here, he turns left because he's blocked. Now he needs to get back to the edge, he's back to the edge. Here it's good because there's room in front of him. There he's blocked to the front. This is looking good. He's blocked, so he moves to the right. Here he's not blocked, he moves forward, he has to turn left. Comes back to the edge here, and so that's good. This simple little bit of if statements here is getting him to walk around the edges. That's exactly what we hoped. Now, let's stop this because this is going to go on and on and on forever and ever and ever because we have while true in there, while true, and so let's stop this, and we don't want this to happen all the time. In fact, maybe we only want this, let's think, when do we want to stop doing this? Well, we certainly want to do this as long as there are still gems, okay? And lots of times we'll be on a gem when we're doing this while loop. So we can say while we're is on gem, then we can keep doing this amount of code. And in fact, as long as we're on a gem, before we do any turning or moving, let's go ahead and collect that gem. Are we on the edge? Are we blocked to the right? And if we are, if we've got room to move in front of us, we'll move in front of us. Otherwise, we'll turn to the left and move forward. Okay? Let's try this and see. I don't think this is going to quite be the end of the solution, but it'll be close. Okay, move forward. Collect this gem. Stay along the edge, collecting gems. Move forward, and yeah, he got sad there. He got sad because he's not on a gem anymore, so he stopped there. So we're going to need two conditions here. Both, he's got to be on a gem, but also, if he's not blocked, we want him to keep doing that. See how he's not blocked here at all? He's not blocked forward. We want him to keep doing this too if he's not blocked. So we can say if you're on a gem or your not is blocked, then keep doing that code. Okay, that's one solution. Let's try this. So he's on a gem, so he's going to keep doing this. And here he's coming to a square where he's not blocked, so he's going to keep doing it. And good. This should work now. We made it through one iteration. Here he's not blocked. Keep doing it. We could get him to stop collecting gems by putting that in a check to see. In fact, let's go ahead and do that. Let's put our collect gem and make sure that only does that if he's on a gem. If is on gem is true, then we want to collect the gem. That's the only time we want to collect the gem. We don't want to do it in those other places where we're just blocked, or where we're not blocked. All right, I'll run this code a little faster. There it goes. Now he should walk all the way around. He won't try to collect the gem here, but here whenever he's on a gem, so he's doing a good job hugging the outer parts of the puzzle whenever he can and collecting gems whenever he can. Hey, there we go. Okay, did a good job. So that was pretty efficient, He only went on squares, that he followed from one gem to the next as well as he could, staying along the outside of the puzzle as much as possible. Now, remember, we did two versions of this. One, we did symmetry, where we saw that there were some patterns that repeated. For example, the four corners pattern, we did one corner and then we just repeated that 4 times. That's nice. This one is a little bit more what we would say general, meaning that if we had a puzzle that wasn't symmetric, but we knew that all the gems were along the outside of it, this would still work. It would still work. It would you'd still follow along the edge of the puzzle, even though it had some funny shape to it, collecting gems and being very efficient about it. But it doesn't rely on any symmetry from the puzzle. It wouldn't have to be a square or a rectangle or something like that. It would work even if it was some very strange shape, but still the gems would be all along the outer edge of the puzzle. So, okay. Good job, everybody. 2 different ways to do something like this and 2 different ways to think about a problem like this. We'll see you next time.